welcome everyone. This is the demonstration for the waste segregator which we have made as a part of our DIY group project. So let me give a brief introduction for the demonstration. These two bins are for dry waste and wet waste respectively as seen from the labels. And in the middle is our waste segregator which is powered by a 12-volt adapter and has an upper platform with a IR sensor and a moisture sensor. The IR sensor detects the waste and moisture sensor distinguishes between dry waste and wet waste, and a servo motor attached which moves accordingly whether it is wet waste or dry waste. And there is further circuitry inside the box which due to its complexity is kept inside the box so that the our device is portable. So you can see on the left is the breadboard, and on the left is the Arduino board, and on the right is the breadboard for connecting various parts of the circuit. So we will try certain examples of dry waste and wet waste and see if our waste segregator works properly or not. So we shall be testing two dry waste, a pen and a sharpener, and two wet waste, an apple slice and a cucumber slice to for our waste segregator in the demonstration. So let's get started. First is the pen. So I will keep the pen on the platform. As you can see, the light goes on. So let's see in which direction. Okay, so as you can see, it goes in the dry waste. So as you can see inside. Now let us try for the apple slice and let's see where it goes. So as we see, it goes in the wet waste bin. So as apple slice was wet waste, so let's do the next. This time we have taken this sharpener and we will put it on our platform. So as you can see, it falls again in the dry waste as it is a dry waste. So next we will try our cucumber slice. So this is the cucumber slice and we will keep it on our platform and let's see. As you can see, it goes again in the wet waste bin, and that completes the demonstration. We have taken two wastes, sharpener and a pen, and apple peel and cucumber peel, and shown and segregated it using our waste segregator as you saw in the video. So that was a demonstration, and
Hello everyone, I am going to be presenting the circuit diagram of our waste segregator. As you can see, first we have our Arduino Uno board and our breadboard. On the top we have our moisture sensor which is connected through a potentiometer, and this green wire which is connected to the analog pin of the Arduino Uno. This basically reads whether an object is dry or wet and returns the analog signal. Over here we have an IR sensor. This is connected to the digital pin of the Arduino Uno through this orange wire. This detects whether an object has been placed on the segregator or not. Over here we have our actuator, our servo motor. This is powered through this 9-volt battery over here. However, since our servo motor only takes 5 volts, so we have used this 5-volt regulator to convert the 9-volt to 5-volt. When an object is placed on the segregator, this IR sensor detects it, and then this moisture sensor checks whether it is dry or wet. And depending on that, the servo motor either rotates clockwise or anti-clockwise, as you must have seen in the demonstration. So that's it. That's the circuit of our segregator explained. Thank you for watching.
So this is the code for our DIY project which we have uploaded to the Arduino Uno. Firstly, we include the servo library and we define some macros over here for the various pins. Then we make a servo class and define the servo object at pin 2. In the setup, we set the pin mode for IR sensor to input and initialize the servo pin with servo at 90 degrees, which is the initial position. Now, inside the loop, we continuously keep reading data from the IR sensor and wait until it detects an object. Upon detecting an object, we delay for 4 seconds so that the moisture sensor can detect the moisture levels correctly. Then, depending on the moisture levels, we either rotate the servo to 45 degrees for wet waste and 105 for dry waste. Then we keep the platform tilted until the object is fallen off the platform with delays of 1 second. And finally, we rotate the servo pin back to its initial position. This delay of 1 second is there so that each loop runs smoothly. Now we'll just compile the code and check it. As you can see, it has compiled successfully. We have also made a flowchart explaining the code.